Hello and welcome once again to Python with Obinkwaju. Today we are looking at sets. So sets are an ordered collection of unique objects or elements. Unordered means that items within sets are not indexed. They are not sequential and therefore cannot be accessed using indexing and slicing. The next thing is that they are unique collection of unique objects. What it means is that within a set, we can't store the same item twice. Every item in a set must be unique. So let's just jump into Jupyter Notebooks to explore this concept better. We are going to create sets, and there are two ways to do that. So let's see the first one. I'll just create a variable and I'll call it my set. To create a set, we use the curly braces and then we'll just assign whatever item that we want. Okay. Now I'll deliberately go ahead and repeat some of the numbers. Right, so that is a set, a valid set. Let's go ahead and then print it. Let's print my set. We end up getting a valid set. However, we realize that every item that was repeated, the repeated ones were omitted. Just the unique items were stored in the set. To actually be certain that we have created a set, let's check the type to be sure. When we check the type, we know that we've created a set. So that is the first way by using the curly braces. We can also use a set constructor to create a set. So to do that, we declare a variable, we bring our assignment operator, then we call the set constructor is a function. Then this function takes in a list. So inside the set constructor, we must pass a list. So I'll just go ahead and then we know how to create a list using square brackets. So I'll just paste the same numbers that was generated up there and I'm going to run that. So this would convert this list into a set and store it into my set 2. If we go ahead and then we print my set 2, we would end up getting the same. Notice that all the unique it only returned just the unique items within that. To be sure, we can go ahead and check the type for this as well, and we end up getting a set. So let's go ahead and then now see how we can add items to a set. To do that, I'm going to create an empty set. I'll just call this a variable. I'll call it empty sets, and we're going to use the set constructor. You've seen that already. So I'll just call the set constructor. And this time, because I'm creating an empty set, I'm just going to just leave parameters empty. When I check the type of my empty set, we realize that we've been able to create a set. However, it is empty. So let's first of all see how we can add. So we have this empty set. To add, we'll just call the add method. So we just say .add, and then we pass in the number that we would want to, or the object that we want. So let's say I want to add 1. If I check empty set now, you realize that it now contains 1. If I update this by adding 2, you check again, it contains 2. So we can keep adding. We can keep adding this, changing just by. So each time you change and you run that, you end up getting. So now let me check that. You realize that now we have 1 up to 5. I'm just going to try to add 3. We run that and still nothing happens. Because 3 is already present in the set, it is going to ignore adding this 1. I'm adding 6 now, it works. If I add 7, it works. If I try to add 7 again, nothing happens. Now let us look at how we can access items in a set. Since they are unordered and therefore we cannot use slicing and indexing, set allows us to use a for loop to iterate over each of the items and then fetch them out. So that's our empty list now. It's no longer empty. It contains all numbers. I'm just going to say, so let's see how I'm going to say for every number in the set, I would want to go ahead and then print that number. If we run this now, you realize that we're able to access each and every number within the set. 1 was accessed, was printed, 2 was accessed, was printed. Let's try to access it using what we know, the indexing. We normally know for indexing, we just call and then we open some sort of brackets and then we pass the index position. So let me pass the index position 0 and run that. and it ends up telling us that set objects is not subscriptable, meaning we can't use the index and position to access items within the set. We are going to look at some operations in sets. The first operation we'll be looking at is called the union operation. So I've created two sets in here, set 1 and set 2. And the union, this is the union symbol, the pipe sign. This can be found, I think, right out above the enter key. You hold shift and you can find it right above the enter key. So we call this a pipe. So the pipe symbol is the union symbol when we are working on sets. So I have set 1 and set 2. If I say set 1 union set 2, and I'm now storing it into a union set, a new variable union called union set. If I go ahead and I run this, I end up getting these numbers. So what is really happening here? Union combines elements from different sets and return them without the duplicates. So you realize that 1 is here. So we are just returning the union of these two sets, but the duplicate will not be repeated. So we realize that 8 is here and there, but we just accessed it once. So that is union. Another way we can either use the pipe symbol or we can use this union method. So to do that, we call our first set, so set 1, and then we say union, then we open the bracket, and the next set would want to unite it with set 1. If I go ahead and I print that, so I stored it in union set 2, if I print that, we'll end up getting the same results. The next operation is the intersection operation. So on the same set, to do that, we use the ampersand. So the ampersand symbols represent intersection in set. So we call the first set and the second set. Let's go ahead and then print that. Let me just print that. So if we print that, we end up getting 8 and then 4. So what is intersection? It returns a set containing elements common to both sets. 8 is here, it is there, so it was picked. 4 is here and there, so it was also picked. So the same way with union, we can either use the symbol ampersand or we can use the method intersection. So to do that, the same way we call our first set, then we say intersection, we open our parentheses, then we pass in the second one. And when we run this, we'll end up getting the same result. The next operation is the difference operator. So the difference operator, we use a dash. So set 1 minus or dash set 2. If we run this, let's see what we get. So what is the difference? The difference returns a set containing elements in the first set, but not in the second set. 3 is here, and it is not there. 5 is here, and it is not there. The same 7. So it returns items that are unique to the first set. In the same way, we can use the difference methods to do that. So you call the first one and then the second one. If we run this, we'll get the same results. The last operator we'll look at is the symmetric difference. So to use the symmetric difference, we use the caret symbol. So I call the first and the second. Let us go ahead and run and see what the symmetric difference actually does. So the symmetric difference, it returns a set containing elements that are in either sets, but not in both. So every item that happens to be in that and that will be ignored. So we realize that 8 happens to appear here and there, and therefore 8 was ignored. So that is what the symmetric difference does. Now let's look at 2 or 3 built-in methods on sets, then we are done for the day. So I'm just going to say, let's use this set. We had a set here. Okay, so let's use my set 2. I think that's long enough. All right, so we have the set and we are going to use some methods on that. So I have the set and I'm just going to call the .remove method on it. So the remove method, what it does is that it removes a specific element from the set. So what element do I want to remove? I would want to remove 9. So I would just go ahead and run that. If we check our set now, you realize that 9 has been taken out. Now let me try to go ahead and remove 9 again. And this time around, it throws an exception. So the remove would remove the item if it is present. However, if the item is not present, it will throw an exception at error. Let us look at another one that is very similar to remove. It is called discard. So the discard method also removes item. So I'm just going to try and remove discard 8 from this. If we check my set 2 now, 8 is gone. Let's try and remove 8 again. We do that and nothing happens. So the difference between the discard and remove is that remove would throw an exception if the item it tries to remove is not present in the set. However, discard will just ignore it. If the item is there, it will remove it. If it is not there, it will just ignore it as if nothing happened. And let's look at another one called the .pop method. So the pop, if I run this and we check, we realize that 1 has been popped. Let me go ahead and then run this again. 2 has been popped. So it pops an arbitrary element from the set. If we check my set now, you realize that 1 has been popped out and 2 has been popped out. Let us run this pop again and it pops out the next 3. So that is what pop does. Then the last method to look at, let's look at .clear. So we have the set and we are going to say .clear. If I run this and I check my set now, it says set. So this is an empty set. It's just like a constructor with an empty set. So the .clear method clears every item within the sets and returns an empty set. These are the few methods you can explore on your own to look at the other available methods. You can just even use the dots and then a tab key to find out some other methods that are available for. So you see that's a symmetric difference that we have. So that is the difference. So just go ahead as an intersection. So you can just explore these ones. The union is also here. Don't forget to like, subscribe, share, and leave a comment. We will meet in our next lesson. Have a nice day. Bye-bye.